Hello, you're welcome to yet another video. This time around, we want to briefly look at a certain concept in mathematics which is quite useful in almost every area, that is change of subject. We're going to look at the basic rules of engagement and how we can, as fast as possible, resolve any of such questions that are given to us. So let's quickly move through. Whenever you are to make a certain variable the subject of an equation, irrespective of wherever the variable is found, assuming it is engaged in a multiplication operation, to undo that multiplication operation, it is recommended that we use the division operation. Whereas the reverse is true, that is, if the variable is involved in a division operation, we make use of a multiplication operation. Now, if the variable is involved in an addition operation, we make use of the additive inverse. Now, the same applies when it is involved in subtraction. We undo it with that of addition. There are others which do not fall under these four categories. They include the radical operation signs. Now, if you have a variable a exponent n, to undo and free this variable a, we will have to express it to the nth root of a. In other words, assuming we have a to the power 3, to actually make a the subject of the equation, we will have to find the cube root of a. Let's try to attempt an example here to appreciate what we are trying to draw home. Make t the subject of the formula k equal m root t minus p over r. Our focus is to make t the subject. Let's observe where t is located. Realize that t is under a radical sign. Now, looking at the question given, this implies we cannot straight away take t out from this radical sign. Rather, break down the operation that is happening outside first. Now we see m to be multiplying the radical, or the multiplying whatever be the result of the radical operation. So, because it is multiplying, we have to undo this multiplication operation between m and whatever that is under the radical using the division sign. That is, we divide both sides by m. In doing so, I believe you agree with me that m is found at found at the right hand. Therefore, dividing the right side by m will nullify m, whereas we have the left side to be k over m, now equated to the radical or the root of t minus p over r. We are a bit closer to unraveling or making t the subject. Now, if you look critically, you realize that we have a root sign serving as an umbrella for t. Now, what do we do? The next thing we can do is to undo this root sign, which is serving as an umbrella for t. Now, since it is a square root, it is recommended that we square both sides of the equation. And so we have root t minus p over r squared equal to k over m all squared. Doing that will therefore nullify the square root sign, which used to serve as an umbrella for t minus p over r, resulting to the left hand side becoming k squared over m squared. Another step closer. Now observe what is happening here. Observe that p is having r as a denominator, whereas p is also having r as a denominator. Now, being a denominator means that an operation of division is occurring between the numerator and the denominator. Now remember, to clear division, we use multiplication. That is, we multiply both sides of the equation by r. Doing that will result with rk squared over m squared. Now, multiplying the right hand side, we know that r will nullify itself. We are therefore left with a negative p, which is associating itself with t at the right hand side. Now, if you remember, if it's a negative, to nullify it, we need to add the additive or the additive inverse of the negative. That is, we add p to both sides. In doing so, the right hand side p will be nullified, leaving p to be at the right hand side. That results to rk squared over m squared plus p. We can make this look more nicer by trying to find a common denominator or making it a common fraction. That is, multiplying m squared by p and then having rk squared plus pm squared all on m squared. And that's resulting to t being the subject of the equation. Thank you for watching, and bye for now.